This is CPM Calculus Chapter 5, number 40. So a rectangle is bounded by the function y is equal to negative x squared plus 5. Here we have the rectangle, here we have the function y, and the x-axis. So it's bounded by these two, and here are the points, right? There's the rectangle. If the base of the rectangle is 2x, what is the height? So here's the base, right? Well, the base, if it's 2x, that means if we're in the middle, right, this is an even function. That means we're going to the right half of that and the left the other half. So that means we're going to the right x and to the left negative x. That means the height of the rectangle is just, if you plug in x into our function, the height is equal to y, which is equal to negative x squared plus 5, right? It's just this value y, okay, which is the point here at x is equal to x. Alright, let's go on to part B. So now we know the height. Part B says, what is the maximum area that the rectangle can obtain? So the area, we know, the area is going to just be the base, which we know is 2x, and the height, which we know is negative x squared plus 5. So that's the area. Let's go ahead and distribute the 2x. So we have negative 2x cubed plus 10x. And to find the maximum area, we want to set this equal to 0. The derivative equal to 0, right? So derivative is negative 6x squared plus 10. Setting that equal to 0. Solving for x, we subtract 10 from both sides. We get negative 6x squared is equal to negative 10. Divide both sides by negative 6. We get x squared is equal to positive 10 over 6. Negatives cancel out, which is equal to 5 over 3. Square root both sides. We get x is equal to plus or minus square root of 5/3, right? Don't forget that we're dealing with actual distance here, so we have to ignore the negative, and we have to say, well, x is just square root of 5/3. Okay? And again, this is going to be a minimum or a maximum, but you can see that we can check this by looking at, well, what is the concavity of our function? Well, a double prime of x is equal to, looking here, is equal to negative 12x, right? So if we plug in our x value, so a double prime of square root of 5 over 3 is going to be negative 12 times square root of 5 over 3. And this right here is a negative number. So since it's negative, that means it's concave down, right? Concave down tells us that, well, voila, it's a maximum, right? So this is our maximum value for x. So what is the maximum area? Well, we got to plug this x back into the area function. So a of x is maximum at, it's the at sign, at x is equal to square root of 5 over 3. So a of square root of 5 over 3 is equal to 2 times x, so it's 2 times square root of 5 over 3. Oops, the whole thing is under the square root. Times negative x squared, negative square root of 5 over 3 squared plus 5. Okay, we can plug this into our calculators. So bring out your calculator. We get 2 times square root of 5 over 3 times negative of, well, I can go ahead and simplify this. Square root and squared cancel out, so that's negative 5 over 3 without the square or the square root plus 5. Close the parentheses. Let my calculator approximate it. Get the exact value for the area is 20 square root of 15 over 9, or approximately, I'm going to click the diamond, enter, or 8.60663, and these are units squared. Okay, so that's the area, and that's the maximum area for our rectangle. Alright, let's go on to part C. Part C says, if you made the rectangle from part B, we just did, and remember the value for x from part B was square root of 5 over 3, right? The whole thing's in the square root. If you made it into a flag and spun it around the x-axis, so if we made this region a flag and then we spin it around the x-axis, we're going to get a cylinder here, right? We're basically making a cylinder. What would be the resulting volume? Alright, so the volume of a cylinder is equal to pi r squared h. Okay, so the radius of this cylinder is the radius of the circle on that it's made of, and the radius then is the height, right, of our rectangle, and the height of our rectangle we know is negative x squared plus 5, and the height of the cylinder is the length across the cylinder. We know that is just times 2x, right? And we know x is square root of 5 over 3, so to find the volume of the cylinder we get pi times negative square root of 5 over 3 squared plus 5 times 2 times square root of 5 over 3. Right? So let's plug this into our calculators, and that's going to give us the volume of the cylinder created. So we get pi times negative, and again we have square root of 5 over 3 squared, so we can just cancel out the square root with the squared, so it's negative 5 over 3 plus 5, right? This pi is going to be distributed to both of these, so I want to make sure I have that in my calculator represented, times 2 square root of 5 over 3. Okay, so I'm missing close parentheses, so I'm missing one right here, right? So let's close it. So that's equal to, I think I did something wrong. Yes, I did. This negative should not be outside the parentheses, so let me go ahead and fix that. It's right here. So we get, it's equal to 20 pi square root of 15 over 9, which is approximately, diamond enter, which is approximately 27.0385, and the units for volume are always units cubed, so we don't have units, so I'm just put units cubed. So that's the volume of the cylinder when we use the dimensions that we found in part B. Alright, let's go on to part D, excuse me again. Part D is the last part of this question. It basically says find x now so that the volume of the rotated rectangle is a maximum. So we don't care about the rectangle's area, we care about the volume, right, of the cylinder is a maximum. So remember, volume is just the formula we had was pi r squared h, since it's a cylinder. This is equal to, well, the radius, remember, was the height of our rectangle, and the height is going to be the y value at x, which is negative x squared plus 5. H is the height here, which is still 2x, right? Let's go ahead and simplify this and distribute everything in. That's equal to 2 pi x times x squared, so negative 2 pi x cubed plus 2 pi x times 5, 10 pi x. Alright? So we're going to take the derivative of the volume, so v prime with respect to x. Right? That's not necessary, but sometimes it helps. V prime is equal to negative 6 pi x squared plus 10 pi. Okay? So when we set this equal to 0, we're going to find our maximum and minimums. So it's set equal to 0. Let's go ahead and solve for x. Subtract 10 pi from both sides. Divide both sides by negative 6 pi. Alright? And here we get negative oops, you know what I forgot to do? I just looked here and I forgot to square this. Let me erase this all because I made a big mistake. So this should be pi r squared h r squared. So this is r, so we need to square it. Okay? So it's not as simple as I had made it out to be. I can multiply 2x and pi, so that's 2 pi x times this squared. So that squared, again, is just negative x squared plus 5 times negative x squared plus 5. And that's equal to x squared. Negative x squared times negative x squared is x to the 4th plus negative x squared times 5 is negative 5x squared. Again, plus 25. Okay, this is just the side bubble work. So this is going to be 2 pi x times x to the 4th minus 5, excuse me, we can combine these, so minus 10x squared plus 25. Distributing the 2 pi x, we get 2 pi x to the 5th minus 20 pi x cubed plus 50 pi x. Okay, now we want to take the derivative to find the maximum and minimums. So v prime is going to be 10 pi x to the 4th minus 60 pi x squared plus 50 pi. Alright, now this is what we want to set equal to 0, right? So let's set it equal to 0, and now we want to solve for x. So what I'm first going to do is just factor out a pi from all these, and actually factor out 10 pi. So if I factor out 10 pi, I'm left with x to the 4th minus 6x squared plus 5 equals to 0. Right? I can divide both sides by 10 pi. And that's going to cancel out here. I'm left with x to the 4th minus 6 x squared plus 5 equals to 0. Alright? So now what I'm able to do is factor this, right? So when I'm factoring this, let's scroll down. You'll notice that I have x to the 4th and x squared. And I'm not used to that, right? I'm used to x squared and x. But you can still factor this in the same ways that you've done x squared and x. Because you can consider this as x squared minus 6 times x squared plus 5 equals to 0. So now you can consider it like a quadratic. If you were to make this another variable, if you were to let w equals to x squared, then you can say this is w squared minus 6w plus 5 equals to 0, right? So you can factor it in using the quadratic equation, or you don't need to do it like that. I'm going to show you a different way. You can go ahead and use the x method. You want to get numbers that multiply together to get 5 and add together to get negative 6. That's going to be negative 5 and negative 1. So this is going to be x squared minus 1 times x squared minus 5 equals to 0. You can go ahead and distribute this back to check that this is the answer, right? We know this method for quadratics, and like we just showed, this is similar to a quadratic in form. But now these are x squared terms. Now that we have them it equal to 0, we can say x squared minus 1 is equal to 0, or x squared minus 5 equals to 0. Now we just solve for x. We get x is equal to plus or minus 1, right? Let's go ahead and show the work. Add 1 to both sides. We get x squared is equal to 1. Square root both sides. We get x is equal to plus or minus 1. Here, we add 5 to both sides. X squared is equal to 5. So x is equal to, after we square root both sides, plus or minus 5, right? X is a dimension, right? It's actually a side. It's the length of part of our rectangle, so it cannot be negative. So that means x is equal to positive 1, or x is equal to the positive square root of 5. X can't be negative for our rectangle, right? So x is 1 or square root of 5. So which one is the maximum? Because we want it to be a max. So there's many ways to find, like there's two ways actually. We could use the first derivative test, right? And then we could basically look at 1 and square root of 5, these regions, right? Or we could use the second derivative test and look at f double prime of 1 and f double prime of square root of 5. Okay, so they're all the same. I'm going to do the first derivative test just for fun. Okay, so to the left of 1 I'm going to use 0. In between 1 and square root of 5 I'm going to use 2. And over here I'm going to use 3. Okay, why can I do that? Because square root of 5 is equal, whoa, what am I writing in here? Square root of 5 is equal to 2.23607, right? So 2 is to the left, 3 is to the right, and 0 is to the left of 1. Okay, so let's plug these in, and we're going to plug them into our derivative. So we're going to start with 0, right? If we plug 0 in, what do we get? 0 times 10 pi 0 minus, this is 0, minus, plus 50 pi is 50 pi, right? There's no x in this, so it's going to be positive. All I care about is that it's positive or negative. And it won't be 0 because 1 and square root of 5 are the only zeros. Plug 2 in. Plugging 2 in, I'm going to use my calculator just because I want to. 10 pi times 2 to the 4th minus 60 pi times 2 squared plus 50 pi. Okay, and my goal is to see is this positive or negative, and it's positive, right? Positive here, and finally finally 3. Okay, so let's go back up. Oops, I just realized I wrote this wrong. It should be 60, not 6, right? Let me make sure I wrote the rest right. 10 pi times 2 to the 4th minus 60. So let me go ahead and make sure if it's positive or negative. Oh, it's negative. So I did this one wrong again. Sorry about all the mistakes. So this is negative. So be careful if you use your calculator or just in general. Little mistakes will change your answer extremely. Okay, and finally we're going to plug in 3. So 2 pi times 3 to the 5th minus 20 pi. Well, I'm plugging the wrong one. I'm supposed to plug it into v prime. Let me start all over. 10 pi times 3 to the 4th. What's going on? 10 pi times 3 to the 4th minus 60 pi times 3 squared plus 50 pi. Okay, Diamond enters, and 1005 point whatever is positive. So that shows us positive increasing, negative decreasing, positive increasing. Which one's the maximum? 1 is the maximum. Square root of 5 is the minimum. Right? So we know 1 is the maximum. So we can go ahead and say at x equals to 1, right, the volume of x, or volume at 1, is equal to, so let's go ahead and look at the volume function, which is 2 pi x to the 5th minus 20 pi x cubed plus 50 pi x. So 2 pi x to the 5th, 2 pi x to the 5th, well, x is 1, minus 20 pi x cubed, minus 20 pi x is 1 cubed, plus 50 pi x, plus 50 pi times 1, and this is the maximum volume. So let's go ahead and enter it in. 2 pi times 1 to the 5th is still 1, minus 20 pi plus 50 pi, right? And what is that equal to? That's equal to 32 pi. Or we can say 100.531. And remember, this is volume, so it's units cubed. So you can have either 100.531 or 32 pi units cubed. So that's going to end for us CPM Calculus Chapter 5, number 40.